Hello and welcome to today's video, which will be a brief introduction to Adaboost. My name is Akhil Vaid, and today I'll be teaching you all about the basic concepts of adaptive boosting or Adaboost. So let's start with the video. So the topics that will be covered today are: firstly, we'll be looking at the introduction and the basic concepts of this algorithm. Then, in the next segment, we will have the mathematical derivation and the proofs associated with the concepts we learn now. And finally, we will be learning the implementation on modern software. So, this will be a three-segment video, and I'll be presenting the first segment, which is the introduction and basic concepts. So, let's start with a brief history of Adaboost. Adaboost is short for adaptive boosting. It is a machine learning algorithm formulated by Yoav Freund and Robert Shapiro. As we can see in the images provided, Yoav Freund is the associate professor at University of California, San Diego, and Robert Shapiro is an American computer scientist at the Computer Science Department at Princeton University. The pair won the Gödel Prize in 2003 for their work on this specific algorithm. So the prerequisites of this video are: first, you should have a thorough understanding of decision trees and the various algorithms that are used to create and analyze data using them. So this is an example decision tree which tells us whether a person is fit or unfit. So in each node of this tree, we can see different decisions, different conditions, uh, or in layman's language, these are specific questions, right? And let's say we have some person A or some person XYZ. So if his age is less than 30, then from the first node, we will go to the left side, which is eat pizza. Then if this person does not eat pizza, then we can classify him as fit. So this is a basic classifier that most of us are introduced when we first learn machine learning. Second, we have random forests. So a random forest is basically many different decision trees which are given the same inputs, but their structures are different, right? And then we take the output of all of these and apply some mathematical operator and get a new output, which we use to classify our example. So, what are the goals of this video? We will be learning three key concepts of Adaboost using decision trees and random forests. Later on, in the next segments, we will discuss the derivation and implementation of Adaboost on some examples. So let's start by using decision trees and random forests to explain the three main concepts behind Adaboost. In random forests, each time a tree is made, the whole tree is made in one go, or we can say a full size tree is made. For example, these are two trees which may be part of some XYZ random forest. So, as you can see, each time a tree is made in a forest, it is made from top to bottom, that is, from root to leaf, in one go. As we can see on the left hand side, some trees may be bigger than others, but there is no predetermined maximum depth. In contrast, in a forest of trees made with Adaboost, the trees are usually just a node and two leaves. For example, we have three such data structures which are just a node represented in blue and two leaves represented in light green. Now we will discuss a new terminology which is a stump. What is a stump? A tree with just one node and two leaves is called stump. As you can see in the diagram, stumps are not great at making classifications. Ponder on this fact and think why this may be the case. This is due to the fact that they can only use one variable to make a decision. For example, we want to classify a person with heart disease or not. And let's say we have four factors such as weight, age, blockage in blood vessels, and blood pressure. Now, when we are using a stump, the stump can only tackle one of these factors. For example, a stump which is corresponding to the blood pressure may be something like if the person's blood pressure is above 90 bpm or beats per minute, then the person may have heart disease. That is how a stump works. Hence, they are called weak learners because they are not great at making classifications. However, the algorithm Adaboost loves to work with weak learners and is the reason why they are most commonly combined. That is, weak learners are combined in Adaboost. Okay, in a random forest, each tree has equal vote on final classification. What does this mean? For example, these three trees are part of some random forest. Then each of these has its own equal vote in the final classification. As you can remember from the diagram shown previously, we will take each of these trees' outputs and then pass it through some mathematical operator to get our final classification. In contrast, in a forest of stumps, now mind our terminology here, forest of stumps. That means we will have more than one stumps in our collection. Made with Adaboost, some stumps may get more say than others in final classification. What does this mean? For example, this is one stump. Here we can see that the parent node in blue is much greater than the two children nodes in green. In contrast with a smaller node, in this stump we can see that the blue parent node is shorter in contrast to this previous node. And a third example where the children are way smaller than those in the previous examples. Here we are using length just to show how much priority we are giving to each stump. In mathematical terms, the priority means the weightage to each stump's output. Okay, let's see the next concept, which is order of creation. In random forest, each decision tree is made independently of the others. What does this mean? Again, we'll take an example of three trees in a random forest. It does not matter whether this one is created first or this one, since all of the three outputs will be taken together and put through the same mathematical operator to give the final result. In contrast, in a forest of stumps made with Adaboost, order is important. For example, we have one stump here. Whatever output we get from this will be passed on to the next stump, and so on to the third. What does this mean? That the errors that the first stump makes will be passed on and influence how the second stump is made. And the errors that the second stump makes influence how the third stump is made, and so on. Let's review the concepts that we have learned till now. Three ideas behind Adaboost are: first, Adaboost combines lots of weak learners to make classifications. The weak learners are almost always stumps. These are some stumps in the diagram. Secondly, some stumps may get more say in classification than others. In mathematical terms, this means that the output of one stump is given more weightage or is scaled higher than other stumps. And third, each stump is made by taking the previous stump's mistakes into account. That is, the order of creation matters, and we have a feedback system so that the final result will depend on the order of each stump created. Conclusion: Adaboost is called adaptive in the sense that subsequent weak learners or stumps are tweaked in favor of those instances misclassified by previous classifiers. That means instances misclassified corresponds to the errors made by the previous stump. Adaboost is sensitive to noisy data and outliers. Why may this be? Because since each stump depends on the previous data, if the first stump uh, comes upon some noisy data, that may cause a small variation in the final result, which may get amplified on and on and on through the various stages and various stumps. Hence, it is sensitive to noisy data. The individual learners can be weak since they are basic binary classifiers. But as long as the performance of each one is slightly better than random guessing, which is not the case here since we have a condition upon which each stump works upon, the final model can be proven to converge to a strong learner. Now we move to the next segment of this video where we explain and get into the mathematical proofs of our three concepts.